which is constantly evolving and bringing the future of cities to life.
Good afternoon, dear ladies and gentlemen. It's a pleasure and honor, especially for you out there in our hybrid event. It's the 5th next International Facade Summit. And today we'll have the real exceptional possibility to have 3 keynote speakers, lecturers, giving us the insights of their work. Today, in addition, just to mention it, we have a hybrid event. So you see people in the camera. We have roughly 50, 55 people here in our next studio by Vicona and Partners in Frankfurt. In addition, close to 500 people out there in the world. We are covering South America, the Americas, until Australia. So 43 countries are now also with us in the live stream. And the live stream will be recorded. So if you want to show it to your kids later, just wait for YouTube 2 days from now. Today, the event is having these 5 lecturers. We will have roughly around, for your understanding, 5 times 25 minutes of presentation, some interaction with the audience here, just giving all of us the possibility to get a little bit flesh to the bones when it comes to the content of your work, of your activities. The activities we are going into the details is nothing more but talking about how to decarbonize our construction industry from an architectural perspective, from a contractor's perspective. It is how to combine circular behavior and digital design. It is how to find the synergy between aesthetics and technology. How to fit together engineering and design. And last but not least, about the triad of simplicity, utility, and sustainability. Said that, I'm happy to have my first key speaker here, but before that, just let me mention who is coming today. It is Torben Østergaard from 3XN, GXN, to be precise, because GXN is the research leg. We have also Oliver Franke from HEN with us, the second lecturer. Then my friend from Sobeck, Werner Sobeck, is coming, giving us a little bit insight into his activity. It's great to have you here and to see a little bit the details on that one. Then Holger Holgermeyer, architect, is coming, presenting us more or less contemporary activities in the Frankfurt area. And last but not least, we have Simone Stannini, coming from London, giving us more or less the view of an engineering and contractor company, Sir Robert McAlpine. Okay, great to have you here in the next studio in Frankfurt. Great to have you out there in the globe, everywhere where you're watching us. Have fun, 2.5 hours. Lean back, relax. And happy to say, Torben, please enter the stage. Give us a little bit activities all around the decarbonization and activities like that. I know that you did a lot of work when it comes to the Cube in Berlin. The IOC in Lausanne is another masterpiece of work. And when I Googled a little bit the details, one project attracted my eye, to Finsbury.
Yes.
To Finsbury because of, we are aluminium people. We have counted roughly 800 tons of aluminium. And we all know that materiality is heavily impacting activities in our construction industry. And this is something I would really like to see a little bit into the detail, how 3XN, GXN is doing it. And I just say one thing, architecture shapes behavior. This is 3XN.
That's a good cue for me to step in.
Yeah.
I'm happy to say that I will not be talking about Finsbury at all today. Actually, I won't. But first of all, I'd like to thank the organizers for having us or asking us to talk today. So I'm Torben Østergaard from 3XN. And 3XN is a company founded in Denmark. These are some images from our studio in Copenhagen. We're around about 175, maybe approaching 200. We have offices around the world, London, Stockholm, Sydney, and New York. So that means that as we speak, I will be able to say good morning to our colleagues in New York and good night to our colleagues in Sydney, which is like a nice gesture. So these are some images there from our offices. It's a long trip, so we eat. So 3XN and GXN, oh, there's no, good. So 3XN, GXN, GXN is our daughter company. It was founded in 2007 to help us doing research in the field of materiality, and now also technology, digitization, and behavioral research. So that means that when we say 3XN, we also have to mention DXN, because we work in tandem. So we try to make this wheel work, that we have a part of us works with praxis, and a part of us works with research and development. Now, we all share the same beliefs in 3XN and GXN, of course. We share the belief that architecture is very much about optimism, because every time an architect is involved, something new is going to happen. As our credo is architecture shapes behavior, as you just mentioned. This is our strong belief that we think architecture, or we believe that architecture can actually positively impact people's behavior, especially when it comes to our social interaction. Now we're embarking on a new voyage, you can say, where we try to see what the link between behavior and architecture and sustainability, what that can mean. That's our next step. Basically, I'm here to talk about cars today. Oh, that's how it looks like. But as we talk about facades and we talk about architecture, we also talk about technology. And it's just interesting to see how things have developed within the car industry. So from 1920 circa to 1970, that's about 50 years. It's pretty obvious that within that period of time, a lot of things happened. I would say between the next 50 years, it appears that not so much happened. They're all expressions of optimism, but if you look at the cars as an expression of, say, the facade, it appears that in the last 50 years, not so much has happened. The argument is, of course, that many things have happened, but it's basically under the hood. If you look at architecture and take, just as an example, take the American skyscraper, within the same period of time, between 20 and 70, many things happened. There was a dramatic development technologically. And even if Mies skyscraper, the Seagram in New York, is still being reproduced around the world, there are new trends and new ideas in the world that we support very much, which actually shows that architecture in that sense is actually ahead of the automotive industry. Because we, in architecture and in the construction industry at large, we are forced to, and we are taking on board the idea of combining progress in terms of how facades and buildings perform altogether. But also we can incorporate sort of the human-centric ideas of how people want to behave. And I think it's not our building, it's from Studio Gang in Chicago, their Aqua Tower. It's a beautiful example of how a very dramatic idea can be taken forward. So I will show you how you had to consider today, do I want to talk about facades as a technological phenomenon, or do I want to talk about architecture? And I do want to talk about architecture. And for us, as in the examples I just showed, the facade is, you could say, that's the skin of the building. But before you even come to the consideration of what is the skin, what should that do for us, we need to establish an architectural body. And that body should, of course, support our ideas on the link between architecture, space, and human behavior, and the opportunities for people. I'll start by going through a project we did finalized 2 years ago, 3 years ago maybe, in Lausanne. Cheers. That is the Olympic headquarters. So, or the headquarters for the Olympic organization. So that is a building that is shaped around a core. It's the building is aiming at assisting the IOC in organizational change, and also in terms of providing maybe some more transparency and all these things that are connected to workplace design. Yeah? So, of course, we have a huge Olympic staircase in the middle of the building. And around this staircase, we have a mix of open and cell offices. And obviously, all these spaces, they require quite a bit of daylight. So the body of the building, which I mentioned, is, of course, a little bit inspired, or not a little bit, it's quite inspired by, sort of, you could say, frozen moments or frozen movement, as by the photo from Muybridge. So we looked for ways to interpret the idea of the movement into the building. And to do that, we did very, as we always do, quite a deep investigation into so what kind of architectural body would be the right here. This is basically it's a roof view. Further introduction not necessary, but what you can see is it's a building that sort of occupies the site in a very organic and then dynamic way, and that has to do with the fact that it sits in a park. Oh, we don't have to stand there. So it sits in the park, and the idea with the building is that first it should offer a lot of transparency, and secondly it should merge well into a green surrounding, the green park. So basically, what the building does, it actually lives in a landscape and adds the movement and offers the transparency. And you could sort of see the lines in the facade, how that flushes with the initial idea. And what it does, the reason for all those movements is because it actually shapes moments and sites where you can have a connection inside out. So the building is not, as you could say, like a monolith. It's more like a building that oozes and breathes with the surroundings and creates little moments where you can sit outside and meander. It also creates, the shaping of the building creates a nice gesture with the entrance. And you can sort of get the overview here. There's some nice roof terrace, solar panels, etc. Now, to follow this idea of the movement, you can sort of see how it reflects the same idea, also in detail, and how the curve of the facade provides this beautiful vision of frozen moments. And to do this, we, as always, try to implement our daughter, GXN, to help us provide the right tools for us to design the complex geometries. So you need this kind of tool to do this kind of geometry, and as always, it's a back and forth. You have a starting point, and then you start exploring things, and then you meet resistance, and then you go back to the initial shape and feed it with new information, which is very practical and very useful when you're in this kind of geometry. Now, we don't want to talk about that. So what it does, it actually acts as also a link between the design stage and the production stage. So when we, as designers, when we work, we produce design and we produce information, and this information should ideally flow straight into manufacturing. There's another token of this here. So the facade, as such, ends up being, of course, it has a lot of symbolism because it's the Olympic movement, but it's not just a pretty box, right? It is also a high performer. So I don't want to drag you with all the details, but it's actually one of the most energy efficient buildings you can think of. It's LEED Platinum version 4. It's Minergie certified. So what we try to do here is to do a building that focuses on technology to achieve high performance, whilst not forgetting that we also need to do beautiful architecture. Yeah. The next shares some of the same principal ideas. Cube Berlin in Berlin. It's a building where we were actually asked to do a building on an empty square in front of the railway station. And actually the starting point for the design was this. That was what the master plan told us to do. It was the so-called B plan. They said, well, you have to do a square box, same height, same length, and we wanted to challenge that a little bit because we felt that the site asked for maybe a more clever and more dynamic answer than just adding a box with 4 equal sides. So we actually went through quite an extensive workshop with the client to investigate, so what does the body want to do? What does the internal spatial organization, what should that do? And last not least, what should the building give back to the site? So we decided to go for a strategy where we sort of kept the outside measurements, thus manipulating the facade, sort of like unboxing the box, trying to manipulate it by pushing in, and then allowing for outside terraces or balconies, then lifting up the facade so you could actually access those balconies. So in a sense, this was our design strategy that we tried to pursue, and so this is an early rendering where you can sort of see that that the building is not sort of a closed monolith, but actually opens up so you can access the building and you can have outside terraces, and you can even have the roof terrace, which was also quite a negotiation with the city to get that through. What was important for us was that the building should work well as a building, but also as a sculpture on the site. So we were looking for solutions where we could actually achieve the balconies and the geometry without sort of making it an add-on, but it actually grew out of the design. So these are some views from the balconies. It's actually quite difficult to understand without people, but it's like there's an inner facade and the outer facade, and that's the facade that acts as a railing. So that happens on all levels in different directions. Now, what we also wanted to achieve was to have a sense of abstractness, or the sculptured effect of the facade and the body. And we achieved that using, we wanted to conceal all the kind of the practicalities that usually go with the building. So we didn't want to see all the mullions, all the doors, all the external solar shading, whilst achieving this kind of reflection of the surroundings. So maybe there is a movie now, maybe not. No, there's not. Should be. Anyway, there you go. So, so this is a stop motion movie made from the opening day. So you can see the construction wasn't all done yet at this point. It was in February 2 years ago. But what you can sort of see is that the building stands as a sculpted volume, and what it does, it actually acts as a huge kaleidoscope almost. that we felt would be on this site, on this location, with those opportunities, and also in dialogue with the city, was the right answer. And what it does, it actually changes character over the day. So depending on the type of daylight, the level of the sun, the building totally changes its appearance. Openable windows everywhere, natural ventilation was required, which means that we actually had to manage the temperature in the cavity of the facade. The cavity, as you will understand, is quite a complex geometry, but this is actually the space where we have the external solar shading sitting here and the airflow going up, which meant that we had to find a type of glazing that would satisfy the idea of a building that would act as a sculpture. That meant that we didn't want to have see-through as a clear glazing. So we actually wanted it to be slightly reflective. And that went hand in hand with the idea of actually managing the temperature in the cavity. So that means that Cube is actually pioneering the idea of having an external facade with integrated solar shading. So it's a hard coating, of course. In terms of the issue of CO2, you can say that Cube Berlin is, even if it's a glazed building, and we needed a lot of glass because it's a very compact body, we needed actually 100% glass, and we wanted that. But the facade performance, together with all the other clever gadgets in the building, solar collectors, etc., means that it's a really good performer. So in a way, we're back to the car again, that buildings, they do need to perform better and better. And by Cube, we've gone the way of technology, you could say, even high tech. I don't want to come into the digitization effort today, but I will just show you a few so you can sort of get a glimpse that the outer skin, the inner skin, and in fact the concrete frame. So basically, the design of the facade was driving the whole perimeter of the building, and this concluded in or resulted in some pretty complex geometries. And to organize all that, of course, we had to basically know everything about the building. So we designed a set of information that the contractor could actually take over and basically run with. Only they didn't. For some reason. I don't know why. Yeah. Good. So the whole idea of the kaleidoscope and the shaping of the building, we wanted that to continue and to make this kind of gesture. We wanted it to be a little, flirtatious with the surroundings. We wanted that to continue on the roof as well. So it's basically the kind of the facade folds onto the roof, which again is, I think, more or less an obligation we have as architects, that we should look at our bodies and see where can we actually do something that would benefit people instead of just making a nice roof. That was the initial request. So obviously, who wouldn't want to have this view? That's clear. And these guys, you've seen that. So basically, what it does, it's a bit of a kaleidoscopic effect, but also a bit of a chameleon that changes over day and overnight. And the Berliner photographers have identified that. And there's like a whole discussion on Instagram on people taking pictures and on that day, and then they come back and take another one, and they report back and they discuss that. And it's nice to have being part of a development where people actually take they embrace what they get. That doesn't happen too often in Berlin, I understand. So, third case, you could say, on the architectural body is a high-rise office tower in Sydney. It's one of these. It's this one. And that is a very special story. It's due to open over the summer. And it was a project that we were invited to do, and we hadn't done any high-rises before. So we took, you could say, what we know and what we can. So we took one of those and basically stacked them and said, so that's our offer on a high-rise. So in terms of shaping, that is literally basically what happened, is that we stacked a size of a building that we were familiar with and sort of put them on top of each other. Then we twisted things a little bit to allow for each of those blocks that they could have their own little garden or external area. Then also what the body should perform or do was that each of these blocks we considered it could be like one office that would have, maybe have these floors, and then they could all have their own atrium, so they could have their communal space within a high-rise building. That was the intention. So we proposed this rendering, and the client was a little bit reluctant. Said, "Are you mad? You don't know what the cost of air is." But in the end, it turned out to be pretty decisive, also for the client. And the idea that the building, also if you're at 30th floor, that you actually have an outside space is kind of key to this design. So basically, that's the rendering from the competition. Things have changed a little bit here, but over construction to almost finalized building. So it does a nice gesture. Long story there. But in terms of the facade, what that does, apart from being a dynamic body, the relief in the facade is probably what is relevant for today's talk, is that during the design, there were a lot of discussions. Is the facade slick, or does it have a relief, or God knows what? So, in able to make a qualified decision, you could sort of do the same building with and without kind of the relief on the facade. So without a relief and with the proposed relief, we actually arrive at about 30% less heat gain on the facade or incoming solar radiation. So in that sense, the technical aspect of protecting a building also becomes a very active part of the architecture. Yes, that's an interesting story. Cheers. So, but the really interesting story is that this building is actually an extension of an existing high-rise, namely this one. So, in terms of how can we maybe look at our cities and the potential of our cities, and look at our cities as a resource that we already have. All the stuff that was built in the 60s and 70s, maybe even the 80s. If we could look at that as a resource, so basically what the design does, it takes off the front, leaves the core, the floor slabs and the structure, and then adds to the front. And by doing that, instead of taking everything down, we reduce or we save approximately 90% of the structural massing. It's quite a lot of CO2, of course, and also a lot of money that you save. And if you remember the picture with the location, think about the number of trucks that have to go and pick up debris in the city center. So in that sense, maybe there was a small or a challenge for the technical engineers, the M&E engineers, in terms of the floor-to-floor height, which was 3.75 meters, I believe. But it's not outrageous. It's doable, but you need to twist things a little bit. So you can say from what we had to you cut up the front and then you add a bit whilst retaining all this is kind of the trick. And I think, we think it's something that could maybe inspire to other buildings around the world. That's quite a clever solution. And then you could, of course, add your architecture if you like. That's what you see there, and nice views, all that. So it's about ready. So before I end, I just want to show one more project, if I have the time. 1 minute. So, doing high rises and IOC headquarters and God knows what. There's always a lot of risk management involved in these things. And we think that for us to actually progress and look into things and try to understand potential futures, we need to do experiments. And maybe the experiments is as important as the prestige projects that we do. So this is a very small design. It's called Circular House. It's or Circle House. It's a little demonstrator of a simple idea, namely the idea that we do as we always do in Denmark. We do things prefab, and we precast concrete elements. We put those together, and then everybody says, "But concrete is the biggest crime." But the trick here is that the concrete is designed in a way so you can, it's designed for a disassembly, you could say. So everything is mechanically fixed, and it's something we've done in collaboration with a contractor, and they have a huge interest in prefab because they want to see concrete as, you could sort of say, an asset. So the idea is that if we can start designing buildings using components that over time can be dismantled and reused in other places, that could potentially be a huge benefit for all of us. And in the end, it's just a small pavilion with a lot of interesting lessons. Reused plastic shingles on the facade. So it's one of those small demonstrators, and I think as an architect and as a human, I think we should do more of those little clever experiments where we dare take a chance and maybe learn something. I think that was it.
Thanks a lot for the extreme brilliant presentation, and I just checked a little bit on time. In addition, I mean, unbelievable, brilliant. I've just seen more or less the fourth project, including more or less this one, which is really great, covering more or less the reduce and reuse aspect for the coming future. But when I just look on the architecture, is really impacting and shaping behavior. What is important for you, for 3XN, to develop your projects? We have seen the projects doing more or less this kind of circularity, the Sydney project. We have seen this behavior design project, the IOC in Lausanne, and we have seen more or less the Cube, which is then reflecting this kind of digital design aspect. Is it coming all by nature into together, or is it you start there and by accident you shape the behavior?
It happens by accident. Yeah. No, I think we thrive by being put forward, or when people put challenges forward and say, well, we have this problem, and there are contradictory requirements. Those are often the moments where new ideas pop up.
Okay.
And I think we also we have a very strong design tradition. So we use our eyes and our hands to shape buildings, together with all the partners that we work with. And in a way, the accident plays a role too, because as we've shown, we do a lot of iterations on the same idea. And when you have 10 next to each other, you can sort of see which is good, which is not so good, and sometimes you make a mistake, and those mistakes can be very fruitful.
Exactly. Yeah.
But in the world of today, where architecture is maybe a little bit of a rocket science discipline, you could say, because there's so many things that you need to consider. Information and simply know-how is key. And that's why we are so happy that we have our partner body, GXN, because so we produce a lot of design and also a lot of information, and they produce a lot of insights, and we kind of involve external partners, which is just super important. And actually, clients, some clients are really future-oriented, and it's kind of interesting to talk to investors these days and see what they're looking at. Just a week ago, we handed in the last design or plans for a building in Germany. Beautiful. And yesterday, I received the question, could you maybe look into what it would mean to do this building in wood? So we all know it, sometimes things come out of by reading the paper.
Exactly.
As simple as that.
Yeah.
You read the paper, you see what's today's challenges. Really interesting. I stumbled over something on the internet, Architizer. They're like the 10 sort of largest challenges for architects. And it was all about getting enough time to sketch by hand, making sure that you get enough paid, and number 10 was, get enough sleep, stuff like that. I think those are probably challenges for architects as a person, but as a profession, I think we need to be very much focused on what's happening outside of our own pond, and understand developments within technology, sociology, anthropology, economy.
Excellent. Torben, thank you so much for your lecture. I mean, he's with us the whole evening, so just bear in mind your questions, and then just...
If you have any questions, we can take them now.
Later on, if it's okay.
Oh, it's later. Yeah, we'll take questions later. Yeah. Okay.
But of course, I mean, we will record it as well, and if the audience is out there, we will just start broadcasting for the entire evening.
All right.
Torben, thanks a lot for everything. Good. Yeah, thanks for the great speech and lecture. The second in the row is Oliver Franke. Oliver, please just come on stage already. He's from Hen Architects, Berlin, Munich, Beijing. You will tell us a little bit the story behind all that. He has made also very remarkable buildings, and he will present some of these. I just like to go a little bit into projects and the wording, and at the end I try to find a meaning behind. Because for me, architecture always should, or at least for me, should bring a kind of meaning. You will display a little bit, hopefully, on Zalando, Merc Innovation Center as well, but Zalando in Berlin. Zalando is an online fashion store, something like that. Let's put it that way. And the point is that he has already finished 2 projects. One is called X and O. Of course, I'm an old gray man, but I Googled what X and O means. I guess you hopefully know it as well. X is the kiss and O is the hug. Okay? And then he will maybe present the Z. Z might stand for the generation Z. Older than 7 years, younger than 22 years. I'm a little bit older than 22, you might admit. So I'm not the Z generation yet, but they are said to be young and mobile. And Zalando is meant to be this retail store, dynamic, and you build in Berlin. Berlin, in addition, is something which is maybe traditionally not very dynamic, because you have this kind of building plot structure with this very famous cube type of buildings as presented by Torben. So we have an inner courtyard, like a more or less a castle around, and this is more or less your building plot. And you change the building concept, you turned the courtyard to the outside, and you twisted the building. Looking forward to get the insight on that, to show us a glimpse of future of your architecture in Hen Architects. And Oliver, he's the head of the envelope engineering, and we'll see a lot of activities around the activities of Hen in these projects. Go ahead. Thank you so much.
Yes, hi, my name is Oliver, and even though he already told you all the story about our Zalando building, I'll try to maybe give you a little bit more insight of what we have been doing and what we are doing at Hen at the moment. I will try this. Okay. For all of you who don't know Hen, we are a steadily growing firm. At the moment, we have 3 locations. Hen originated in Munich. We have a very strong practice in Berlin now, and of course in Beijing. All of these 3 offices roughly the same size at the moment. Yeah, we are very internationally, if it comes to our employees. We are about 360 plus people. And as you can see, with the practice in the 3rd generation already, we also have quite some experience. Maybe a few words about how Hen actually is structured and how we like to work. At Hen, we have this tradition already that we are set up in strategic expertises. I always call them task groups. So we have all these experts that we try to group up, and then for every project, strategically join the forces together to basically come up with a well-fitting solution for every topic, every task, every plot. And one of these expertises is the building envelope team, which I represent here today. And obviously, as the title says, we are mainly focusing on the facade design parts. We are very early on in the projects trying to support our colleagues from the studio, from the design studio, in terms of the design of the facade, the variations, the studies, to basically help them to find the right appearance, to find the right face, the identity of the building on the outside. And then obviously the next really quick step is from the design into the technology of the facade, the system, everything that has to do with how do we actually build the thing. And for us at Hen, quite a few of our projects have this topic of the light room, industrial side, to more like a tech campus. It changes with what the company does. It changes together with the company. And you can see here in the front the Emanuel Merc Platz, which is basically in the heart and the new entrance to this Merc campus. And on the sides here, you can see the historic Merc buildings that have been there for quite a long time. And in the center, now with the evolving of the campus, we introduced this new structure, this new house with a rather modern and a very transparent look on purpose. It's the gateway to the Merc campus. This is basically the entrance area where you can already see the modern structure and that there's something special and unusual going on inside. And I will show you in a minute the interior structure of the Merc project. And it's basically the result of a long and very interesting process of analyzing the needs and the wishes of our client and the people who work here. And it's always very interesting. The more you talk to your clients about what they actually want to do in their building and how they want to work there and how they imagine it to look, you find out that this is something, that's a topic that really needs to be properly investigated. And then after a while, you find out that there is a certain necessity for connection, for concentration and all these things. And you spread this out. And so we came up with a with the idea of how Merc works, how the people want to use the building, and then we actually try to make a three-dimensional structure out of this to make the building. So here, rather a flat version organized in 2D, we kind of took the structure and just extruded it and tried to fill the center of this building with a highly dynamic space. And here you can see already a little bit the final result. In the middle, we have this sloping area, like a acceleration place for people, the circulation core of the building, highly connected, highly communicative structure, and on the sides and the perimeter of the building, it's a bit more concentrated spaces, workspaces for the users. This is then how the core of the building looks. It's this slowly spiraling upward fluid space that connects all the levels together. There are no walls, there are no doors. This is all one. It's a very sculptural structure in the center. And you can see here how we looked at this in the model phase. It always had to be the fluent and continuous space that basically connects every single layer of this building. And the section, I think it shows quite well. Here in the middle, we have the circulation area, and then with type of a split level layout, we always have these double height spaces that we were able to program with the functions needed. Here we have actually a look on the right side, obviously the spiraling core, the spiraling center of the building. And then here you can see a project-related area on one side. We also introduced with a more open space, like what we call the space a university, where you can exchange knowledge, people can meet. It's really more like a campus idea within this house. Workshops to actually, it's a hands-on space where you can use mechanical equipment, you can really test and practice stuff. A marketplace, just another space for a bit informal communication, to exchange ideas, to just get away from this too boring workspace everybody knows and what we are all a bit sick of, basically. And then obviously the core piece, the circulation space. And I picked this picture here today because we are also here to talk a little bit about Facade. The question is always, a space like this, so dynamic and so sculptural, how do you react to this with the facade, with the envelope of a house? I think you also, Tom, you showed some really nice example how you did this with the Olympic building. And here for this project, we kind of did a different approach. So we have the very dynamic interior structure, the interior space, and the facade is a little bit the contrapoint to this. It's a rather subtle, high transparent glass facade in a double layer, and it's a really subtle design, basically showing a little bit of this double height split level structure to the outside. But in the end, the only difference we make here is using these glass panels and tilting them in slightly different angles to transport this idea of the double height space out to the facade. Other than that, rather simple, a very elegant approach, as I think, and then the idea of having the old historical buildings from Merc kind of reflected, so wherever you stand on the Emanuel Merc Plaza, you kind of always have this reflection of the old Merc buildings inside. As I said before, maybe the fifth facade, here obviously the roof. I would say it's a one-to-one continuation of the spiral we have in the middle, really just extended and cut into the roof as a light roof, in this case, bringing down daylight all the way through, very well working with the spiral idea. And I think it also manages to actually introduce another quality to the space. Yeah, okay, this was our first project situated in Darmstadt. Now, as you already mentioned, here is our Zalando headquarter in Berlin, which is already finished. It's for Berlin quite an interesting building, and I would like to start explaining a bit why and where it's situated. So Berlin has this part alongside the Rhine. It's the part of Friedrichshain, and Zalando. I think Zalando itself, they call them an online platform for fashion and lifestyle. Obviously, a very, very quick growing market, and Zalando, a breathtakingly quick growing brand. And here the goal was to basically pull together all these offices and spaces they had to rent over the last years throughout the city, trying to pull together all of their parts, marketing, fashion, all of these parts of the brand, to unify them under one roof. Yeah, as we already heard a little bit, the Berlin block is the main urban structure we have. It's a structure that is characterized by the courtyard typology. And so the Zalando campus in Berlin is actually by now made of 3 buildings. This is the second part we are looking at right now. And we decided to turn the classical Berlin block inside out, to kind of connect the building more to the urban space and to also connect the buildings stronger to each other. And we also kind of tilted the axis to get a higher degree of communication in between these buildings. The outcome is a rather interesting shape, something that is giving really character and identity to this building. And you can see really nicely these cut out, these voids that basically let the building interact with the urban space. And they also are, because of their shape and their sharp edges, they are quite a sight, I think. Yeah. So we can talk a little bit about the interior structure. I talked about the diagonal axes. These are, as you can see here, you enter through one of these axes, and from the center, we have an element that we call the vertical marketplace, which is basically the vertical circulation of the building. You can see on the right side, we have all these functions for all the employees, all the public functions, auditorium and so on, located in the ground floor. And then we have a large central staircase, which at the same time is a meeting point that then starts the vertical circulation into the upper parts of the building. This is what we have in the center, and right next to the center, connecting on one side to the courtyard and on the other side also to the facade, we have the spaces that we call the living rooms. This would be here, and you can see they are like a connector of the courtyard in the middle and the daylight-giving facade on the outside. And these parts are basically for an informal meet and greet where people can just communicate and talk about what they have been doing so far. The connection on the levels we achieve by using what we call for a fashion company the catwalks. The catwalks are, in this case, runways basically with a high transparent and light-filled space to connect the different parts of the building on the horizontal level. And then next to this, basically the neighborhoods that are always alongside these curved facades, which are more classical working environments, as you can see here, but also with a special focus on keeping a high transparency and a very high quality for the workspaces. Yeah, so the question, obviously, a building like this, how do you go about facade design here? This characteristic voids through the buildings, we decided, as you have seen earlier, we decided to use two different types of facades. One that is rather transparent, a translucent and even partially closed facade, and the second one with a high transparency and a high connection, visual connection to the outside. Okay, this would be the first type that goes along the streetscape, and then these really transparent void facades that are together then basically forming this quite characteristic look of the building. Again, the topic of the fifth facade, the light roof also here, basically giving us the chance to fill the vertical marketplace with quite some daylight, and it also kind of activates the space in the center, which then makes it usable, and makes it usable in such a good way that we even in the end decided on the upper levels to locate temporary workspaces around this. And I think it's quite a good looking space here. I talked about unifying all these different locations in one spot. This was the first. This was the O. This is then obviously the double X, and you can already see down here that there is this third plot, which also now belongs to Zalando, and this is the third project. Just to give you a quick look, it's under construction at the moment. It follows a bit the same idea with these void spaces, but the void spaces in this project actually become an interior courtyard. So we are not just cutting this out of the urban space, but we will wrap it with a glass facade. So the Z actually is a moving space up to the top, and also under for the daylight usage, obviously, these courtyards kind of help us to program the space in a way with a lot of quality and daylight for the workspaces. This is how we hope it will look in the end. And as I said, it's already under construction. I think 2 weeks ago or so, we had the topping out ceremony in Berlin, and we are really anxious to see how this is going to continue in the next month. Now, maybe this is one project which we are very excited about. At the moment, it's a competition we won, I think, end of last year. It's what we call the Brainergy Hub. And Brainergy Hub is a development. It's basically a science campus in the west of Germany. It's close to Cologne, and it has a very interesting idea. It's a campus of different buildings, all linked together by an energy network. And what these buildings do is they all will generate and store energy in different ways, as you can see here. Anything from solar power, wind power will have a part in this energy net. And then one building in the center, the hub, as you can see on the right side, is the building where all of these, where this entire energy network will be monitored and basically steered. So you can see here how this is from the competition brief. This is how everybody thought that the connection is, and then this was the urban design proposal for how the Brainergy Hub should actually look. And then once we entered the competition and we really looked at how this type of building in the core of this entire campus should look, we kind of found out that we need to dig a bit deeper and find out what the context of this area actually is. But as it is with new developments, there is basically no context at the moment because there is nothing built yet. It's all to come in the future. So basically for us, the only context we could find was a bit abstract. And it's the largest energy-giving moment we have in our civilization. It's the sun. And we kind of felt that maybe this is a good point to start thinking about the structure of the building, rather using like the proposed rectangular standard volume. We were thinking about using rather a very omnicircular structure, which is much more inclusive. And so we came up with something that was basically very different, or even the opposite of what was shown in the master plan so far. Our Brainergy Hub now consists of a highly modular structure wrapped with a circle around it, and has a quite different look, I think, from what was imagined at the very beginning. So it's a wood hybrid structure with these rings going around it, also carrying PV cells and modules. I think these models show quite nicely that for this function of the core piece of this campus, the round structure works quite well, and it gives it this outstanding shape to basically show its role in this context. Here we can see a little bit how it's set up. It's as I said, it's a modular structure, wood-concrete hybrid in this grid idea, and the revolving ring, which then has the solar panels and some balconies to it added on top of it, basically highly connecting it to the landscape around it and giving everybody access from all the sides. A typical floor plan, you can see here in the center, the vertical circulation, and then around this we have the functions that are specific to the floor, and then going to the outside, to the perimeter of the building, we have the workspaces, and then the ring going all around it, basically giving all of these informal balcony situations some space. Here's an interior view where we try to keep this decided to keep the modular structure very visible, because we think it's important to see how the building is organized, how the structure works. And then later on, we also did a daylight study, and we found out that for optimal daylighting inside, we needed to introduce these 4 courtyards and make a glazed roof for the circulation space, so that basically every little spot in the house is well lit. The top floor is a roof garden, basically, with all the PVs on the very top. And this is the view we have from the campus looking back over the lake, where you can see how the building hovers over the landscape and has a high accessibility to it. This is what I talked about earlier, the highly modular structure, which we can basically feel as something that can be easily reused, it can be extended, it can be changed, and is a highly flexible and adaptable structure for this building. Yeah, obviously here, as you have seen on the first few renderings, the facade is a quite interesting topic. With the rectangular structure and the circle around it, we instantly generated multi-layer facades. And the facade is a little bit a balance between high-tech and low-tech. We have rather simple elements for the sun protection. We use operable windows for natural ventilation. We have light shelves to transport the daylight further into the space. And in these light shelves, we also include elements for heating and cooling. So it's a bit low-tech, it's a bit high-tech, depending a bit what you need. Yeah, it's not always only the high-tech solution that make a building working well, but I think it's the combination. And then one of the main features with these round balconies is that we actually have these movable PV elements that are basically rotating on the ring, obviously not the full circle, but we use these rotation panels to obviously maximize the energy output, since it's following the sun throughout the day, and at the same time these panels can help us, as you can see down here, to protect the house from overheating and to reduce the radiation. So it's basically also at the same time a very effective type of sun shading. Yeah, and then obviously the look of the house is very distinct, and for us this is a very good example of a lighthouse project, a beacon project for the sustainable campus. Yeah, okay, this is from my side, and thank you for my colleagues at Hen.
Oliver, thank you so much for your lecture. I was just a little bit triggered by, because you are the envelope and not the facade heading off. So you have the fifth facade always in mind, and I've seen all this project have the fifth facade, which is more or less the most important part of your architecture. Why do you put so much emphasis on the fifth facade? What is the advantage for the user? What is the advantage for architecture?
Well, I think at Hen we always try to activate not only the space. It's a very old school approach to just have always the areas close to a facade being the nice spaces. And we kind of feel circulation spaces that are naturally in the center of the house. The core of the building is an important part. It is the core, and you need to activate it. You need to give it a better quality. And so if you look at our projects, if it's a high-rise project with a footprint building, or if it's any of these buildings I just showed you, the center is the center. It's the core. And we want to use the core as a communicative space. And for this, people will only use this if it has a certain quality to it. And I think daylight is the main part in this. Yeah.
So the quality of life is the fifth facade.
I think so, yeah.
To a certain degree. Oliver, thank you so much.
Thank you.
The third speaker in the row is Timo Schmidt. Timo, just come on stage from Werner Sobeck AG. More or less the brief is to connect engineering and design. This is a little bit Werner Sobeck mantra, I would put it that way. But Timo, in addition, made his PhD in the medicine area in Tübingen. Worthwhile to mention. And in addition, he's professor for facade engineering in Augsburg, close to Ulm, close to Munich. And he's heading the facade design part. He's part of the, I have to mention this, E2D. It is more or less energy efficient facade design. And the education here, by the way, I have to give to the former students in Aalborg all my kindest regards, because they're also watching us now. They're combining excellently engineering aspects with architecture, trying to bridge the languages between engineers and architects. So if you are short on people who are well educated in these fields, contact that guy later on. Okay, Timo, all the best. Yeah, thanks for your lecture. Yeah.
Werner, thank you very much for the kind introduction, and a very warm welcome here to all the people in the studio, and a very warm welcome to everybody at home in front of the computer. It's now very tough to speak after the two first speakers, and I want to make it anyway completely different. So I have just one project I brought with me, and it's actually not even finished. It's in the building process, and I want to go with that project very much into detail and show some insights out of this project. And it's Wassel Tower in Dubai, which is an extremely complicated project if we talk about energy efficiency. It's a high-rise in Dubai. And I call it form follows well-being, or an approach to human-centered facade design. And we can ask all ourselves, is this possible to have a human-centered facade design? Yes or no? Just briefly to the project, Wassel Tower is located in downtown Dubai. It's alongside the Sheikh Zayed Road. It's connected with Burj Khalifa by the city walk, so it's really a prime property, and therefore it's probably worth going up the 302 meter in height, because it's like so downtown, and I think there are a few buildings which are just allowed to go to that height, even if it's from an energetic point of view and a material point of view. We all know this is complicated, and this is exactly the reason why I want to talk about this building, because it challenged us so much. So briefly to the structure, we had the possibility, or first to our team, we had the possibility to work as general planners. We had UN Studio as the architects with us, and we did the structural engineering, facade engineering, MEP, acoustic planning, sustainability, consultancy. So we had all the options to make this a good building. So, and actually that's what we tried to do, and we faced a lot of challenges. So to the structure of the tower itself, we have a residence level at the top, we have a guest room level, a hotel in the middle of the tower, and we have offices at the lower part of the tower. And the overall concept was, it's actually the title, good for the people and good for the environment. So we at Werner Sobeck, so we are building a lot of Energy Plus houses, and we are into that topic, but getting a 302 meter high tower. So this is a challenge, and it was mentioned by Ben van Berkel. It's a concept of health, comfort, and well-being. So how to implement health into a building. So it started, if we talk about comfort, or let's say the social well-being as well. So that was already several lobbies, a garden lobby, a lot of green inside the building, a spa lobby, a sky lobby, a rooftop lobby. So try to get social contacts. It's a small city inside one house, so there's a lot of connectivity. So that was the first part of the architecture by the architects, and then the concept by the architects of UN Studio. They described it as a classic Contrapposto movement. So it's like a counterpoise movement. If you have all your body weight on one leg, and then you get into that twist. We know that from classical sculptures. So that was the idea, to transport that also to the outside. So it's the external view, and it was emphasized here by that vertical boulevard, which runs on two seams around the building. And then the twist was further emphasized, that the facade fins at the outside, they also do that movement. So there's a lot of dynamic, but all the dynamic and all that architecture, this is not necessarily enhanced comfort where the client was asking for, and where we had the idea to do so. So if you talk about comfort, we have the thermal comfort, we have the humidity, acoustics, quality, the air quality, security, and of course visual quality, and this is visual comfort. And this is the point today I want to point out, because I think in all our planning we do so far, we completely underestimate the visual comfort. So we calculate everything, it's all very pretty good implemented in our code so far, but we do not really have a code on our view, what we see, so, and we can't really measure that. And this is what we try to do. And I just brought one slide out of the World Green Building Council, where they had a few numbers how important the outside view is. So we can have a better mental function by up to 25%. This is a lot. So a better call, a faster call processing of up to 12%, shorter stay at the hospital by minus 8.5%. And this is just the views, but how to measure the views. And then if we go to productivity, to daylight support, so more productivity of around 18%. So this is also an economic factor if we have like sufficient daylight inside our houses. So, and of course at the university, because I said I have half of the talk is stuff from the university. So we looked at those papers and we thought of, is that correct? And those figures and numbers are correct. So we looked at all the background literature we found, and to be very honest, we have to make more research on that. So there's just a very few papers which we found describing that. But then on the other hand, looking at retail and the increase up to 40%, I mean, those guys who want to sell something with the daylight, they did tons of research and they come up with the results up to 40%. So my guess would be, so it's even more important than we think of that and those numbers. So, and we have to look into that visual comfort in, much more. So it's also 88% of all respondents in a Foresight survey named daylight as the most important criterion when choosing their workspace. And furthermore, 80% of the information are captured by the eyes. So, and we actually use 25% of our energy budget to process that information. And that was actually the result why you see here an interior of that Wassel Tower, why that daylight is such an important factor, and why the view is so important. And of course, if you build a high-rise and you are in such a prime property location, you have the view to the sea on the one hand side, you see Burj Khalifa on the other side, and you look along the coastal sides on the other four sides. So you, of course, want to open the facade, but then we are talking about energy efficiency, and we open in Dubai a facade so that we enhance the view. And we all know about the solar radiation and the energy which goes into that. And I mean, this is what we do with our building industry. It's like our world is not just like one bite in the apple, it's like already eaten up. So we have 50% of the natural resources. You all know the figures very well, 35% of the energy consumption. So the first question is, how much is the facade involved in that? What is the relevance of the facade of all those figures? And we did that by analyzing the criteria of the German Sustainable Council. So if you look all over the criteria, having economical quality, technical quality, process quality, so the facade is involved in 44% of all the criteria. But if we now pick out the ecological quality, sorry for that, it got a little bit mixed here. So if we look into the ecological quality, we have 74% where the facade is involved in the criteria. So the facade is the most important component if we talk about energy efficiency, but it's also, I think, from my personal meaning, the most important component if we talk about well-being, because there's a lot of things. So we are in a dilemma which we have to solve and which we obviously can't really solve, and that's why I think we have to do so many analyses on that. And now going back to the tower, so and the answers which like our codes give us, and it doesn't really make a difference if we look to the Dubai codes and the solar radiation which we have in Dubai, or if we look to the German codes and what we get for the heat production in summer in the German codes, compared to the different levels of the sun, it's quite comparable. And we are very, very much limited. So here we had the reduction of having just 40% of transparent facade on south, east, and west, and maximum 60% of a transparent facade on the north side. And then if you look to the shading coefficient, it's very low, so there's almost no light transmittance in the glazing which are allowed. But I think if we build in Germany, we get similar problems. So we always get like heat protection in summer is always dominant, and we do not really look for the visual comfort. So what we did here, of course, we have a distance to the core of 12 meters, which is quite a lot. And of course, we did a lot of daylight analysis and tried to get that pretty good. And the orange line here is a daylight factor of 2.2, and this is pretty good. What could be achieved here in the hotel and in the hotel room, I mean, you are not like the whole day within the hotel room, so we don't even need that much. This is all fine, but we run into really big problems if we look at offices. So, and I want to explain that with one slide, which looks rather complicated, but it's very much simple. So just so that we think a little bit about the natural daylight and artificial daylight. In general, we spend around 88% in lighting, artificial lighting in our buildings. But if we go to non-residential buildings, we already spend around 18%. So this equals 27 kilowatt hours per square meters a day. So, but if we now think, this is just like non-residential buildings, but we are talking about offices. So offices are much more daylight needed. So we have a plus 63%. But this is final energy, not primary energy. So going back to primary energy for electricity, in Germany we have a factor of 1.8, so it's another 80%. And then if we think about well-being, so what do we need? So do we need to activate ourselves? Do we need a special melanopic positive circadian lighting? So then it's another 25% if we go into that very high quality light, what we need. We get that for free as a daylight, but we can also do it artificially. And then if you see the energy consumption, so this is quite a lot. And here in the schematic design value for the Wassel Tower, we had already 80% of the energy use for artificial lighting. But this is hotel and residential, not office. It's mainly hotel and residential. And it's not the circadian lighting. So it's much more than the cooling effect. So if we now go into an office tower, so we really have to think if we have to go to more natural daylight, not just because of like the well-being effect, also because I think we can save energy in doing so. And this is, I think, not correctly in our codes. And then there's something more. We have to look at the light a little bit more specific. As Werner already mentioned, I was too long in the medical department, so you get a few slides, but you should know them already from your biology, what you had in school. We all know something about like the rods and the cones and the scopic seeing and the photopic seeing. We know our you know those curves, I think, and we actually, the receptors are here in the back of the eye. But there is also, beside the visual system, there is a so-called non-visual system. And this one we also know. So we have in the UVB, UVA, we have some pigmentation, which we actually like usually, but then we have also like the more dangerous radiation. We have the vitamin D photosynthesis, where we always talk about it's not that important. Go out half an hour a day. I think that's enough. We don't want to let like the UV into the building. And then we have, of course, in the infrared, the nice warming up. So it's nice to have that, but it's also not that relevant for our body. But there's also something we seldom talk about, the so-called melanopic effect. So that wakes us up, that activates us. And this is in a wavelength quite specifically of 490 nanometer. And we collect that with ganglion cells here in the lower part of the eye. And this is very interesting. So it's inside the eye, but it's nothing to do with our visual system. And this goes directly to the brain. And here we wake up. So here it's like the suppression of melatonin. And if we now compare that with LED lighting, so this is where the usual LEDs, they have the low point. This is very interesting, I think. There are some optimized LEDs who shift that into that zone, but it's another energy consumption if we do so. So yeah, I'm the lobbyist for natural daylight because there are not that many of them. So what I think is it's extremely tricky what we want to do, but we should consider the facade as a chance and not just only as a risk. So we have a very small footprint, but we have 20 times as much in this tower facade area as floor area. And yeah, we should use that facade to harvest energy. And in that tower, there was made a lot of analysis, of course, how to harvest energy. And it's very tricky because we have the sand in the air, we have a huge pollution of the photovoltaic panels, and it's not that easy, but it was analyzed in a lot of reports. And finally, we came to the result, let's build an energy cube concept, so where you have access for cleaning, where you have shorter connection lines of the electricity connecting the photovoltaics. So this was actually the outcome out of that. But I want to, as we are here in the next studio, I want to go to the facade and refer a little bit more to the facade and the facade concept. As I already said, so we are twisting around the tower, and so the facade is into a parallelogram shaped way, and we have always 90 centimeter elements, and here we have a 1 meter 80, and then we have the spandrel panel, so in the end we have the 40% and the 60%, but within the twist of the tower, so we have not just like the parallelogram, so we have inclination to the outside, and we have an inclination to the inside as well. And what we used is what your standard use for a high-rise tower, a unitized system having 2 half shells, and you need to take all the movements within a high-rise, so that's no problem for a regular standard facade. It's not a problem if you go into a parallelized system. You can do the inclination, but if you have both, like a rotation and the inclination, so you get a problem at your vertical mullions. And so this was a really tough problem to solve. And so our approach was in the background that, okay, we go for rectangular planning. So that was actually our idea, even if finally the contractor decided to do it differently. But I think the approach was correct, so that we have the parallelogram here inside that unit, and then we have 2 triangulars. So if you have the slab edges, if they are not parallel to each other, so if the slab edges tilt, so we can use the triangulars to bend it into the direction. And we found a system which run even through all those very, very complicated curves. And you see here one of the extreme situations where we have like twists of 240 millimeters. And anyway, we managed to build like a mass of the units completely planar. And then we have a certain amount of units which get cold bent up to 30 millimeters. And then in the very extreme parts, we just have adapter frames. So that is actually one system which easily run around the tower. Easily is not that easy, but I thought was a very good idea. And then we went into that energy discussion. So how to further more save energy, and how can we utilize the fins to do so? And there was analysis from 2015 already, when we thought we need a geometrical feedback, not just like an optimization of some values. And we had, in the basic concept, we took 2 points in the fin, like the upper and the lower point, and we gave them a certain freedom, and then we made a parametric optimization using an evolutionary solver to do so. And then we tried to run natural daylight, light transmittance, as a daylight factor inside the building against overheating in summer. And we got millions of results, and it's actually a lot of calculation, and we a little bit underestimated the amount, but we got a basic idea where the best position of the lamellas would be, and I think nowadays we are much, like almost 7 years later, we can do that even much better. So the computers get much faster, and there are many more programs who involve that already. So we ended up finally, it was also an architectural decision in 4 different lamella types. And it was like the starting point, natural daylight versus heat protection in summer with a geometrical feedback. This is what we usually miss as architects. And what we took to university was then, if we can do so, can we do that with a visual, like with a seeing, with the outlook as well? Is there a measurable parameter which we can optimize where the windows are? So, and we found, of course, literature in the European codes. So there is a measurement how you can look at the quality of the view. And it's mainly dominated by the horizontal angle you see, by the vertical angle, by the sighting distance, how far you can see. And I think most relevant is like the information you get, the number of recognizable levels. It's the sky, the landscape, and the ground. And because here in the sky you see the weather information, you have a dynamic, and the dynamic view is so important. And at the ground line you also have a dynamic information, and that's why those number of recognizable levels is very important. So those are the parameters, and we of course also thought about the quality of the view, and this is actually very complicated to describe, and I'm not sure if we can do so or if we should do so, but we tried at least to do. And within like the computer process, it's easy to implement, but the real information, is it positive or negative? This is hard to do, but at least there is a system behind. And then we went into optimization, and we did that for the hotel rooms, for the offices, and we did that for residential. That was a work at the university, and we added a kindergarten and a hospital room. So those are the optimization rooms, and then we calculated the percentage of predicted dissatisfied people by the thermal load compared to the visual quality. So, but we didn't calculate the daylight factor in, so it was just visual against overheating. And the interesting part of the outcome, so this is just the result, so that you had the different persons, so that's person A, person B, and their location, and then you find we see that here. Yeah, you can find an optimum, and you have here the percentage of predicted percentage of dissatisfied people, and the smaller the circle is, as better it will be. So there is an optimum in width and in height of the window. And so those are the results, and it was very interesting to see. I mean, they are always different in each story, so because you have different seeing angles, but you see the windows are not there where we expect them. If you talk to an energy consultant, the window will be always due to the daylight at the top, but never at the bottom. So we as architects initially do that, often correct. So we have windows from the ceiling to the floor, but everybody tells us all the time that's wrong. So don't do the balustrade. But if we look at the visual comfort itself, so there are those windows extremely relevant. And I think this was a very nice outcome, and it was very inspiring, so that there is a reason to do those windows if we take that into account and if we calculate that. And so now we are working on, and we want to push that to another level. So, and we think that all those technical parameters, they are too complicated to discuss. It's really very complicated. So we thought we need to have a more simple system, and there is an author in London called Hank, and they wrote a very interesting paper in 2019, and they said if we talk about well-being, we talk about indoor environmental quality, about social well-being, eudaimonic, personal well-being, hedonic, subjective well-being, mental health, physical health, productivity. So what do we want to have? And I mean, the most complicated part is to define what we want to have. And so if I go now to an office, I would say, I want to have the social well-being and I want to have the productivity. And can't we find a system? So, and that's what we are working on right now, to go from the well-being criteria to the well-being components, light, ventilation, acoustic, and then into facade components. And of course, everything what happens here in between need to be done by many people. But I think we already opened up the platform to do so with the final target of, so that if we have like the task of making a well-being tower, concentrating on those topics, so that we have a basic discussion system at the very beginning, because that can save a lot of energy, because we do not need all the quality in all the spaces. There are many spaces where we just do not need that many quality. And then coming from here, from the defined well-being to our facade components or other components. So that's the way we're working on. And I think this is very challenging, and we are far away from really reaching that, but we hardly work on that. And yeah, that's it for today. Thank you very, very much for your attention. And I'm done.
Timo, thanks a lot. I mean, I just have to remind us, we also have a small subline behind more or less, or below more or less the International Facade Summit, which is called Think Globally, Build Locally. How much of your engineering and scientific approach was able to make in reality in the Basel Tower?
Oh, not that much, to be very honest, yeah. But it's still in the process, and I think we did really a lot in the concept phase, and then brought it to the client. And but it's yeah, many of the topics what I was presenting, they are far away. They went into research, but I think from all the well-being components in the interior, that will be a fantastic building inside. And so the architects did, I think, a very good job. And
studio.
I want to see once that's finished. So I think they brought a lot of ideas inside, and intuitively, I think they did most of the components correct. But what I was missing was like a measuring system of can we measure that? Is there a way to prove that? We always talk about the same, it needs some green and we need light and we don't define it. But I think we really carefully have to define that very well, so not letting too much light inside, otherwise it will kill us energetically, but having too little light inside, so then we do it technically, that's also not the target. So I just took all those topics to the university and thought, okay, let's find a way to solve that, and not just by intuition do it correct.
Yeah, okay.
That is.
So natural light will keep me awake during my office hours.
Yeah.
Okay.
You need it between 9 and 11. It would be the best time. Then you can lower it down again once
Cool.
you're activated.
Thank you, Timo. Thank you so much.
Thank you.
Yeah.
Thank you so much for giving me the opportunity.
The next speaker is Holger Holgermeyer from Holgermeyer Architektur, Frankfurt, but also located in Munich. Architecture with passion, I have taken from your homepage, Holger.
Yeah.
And I'm really curious to see a little bit how this is. And when we talk about our industry in the future, in the next time, we can have a lot of new high-rise buildings, everything like that. But as Torben has also presented in Sydney, there might be an existing building stock, and we have to give the existing building stock maybe a second life. So revitalize what is possible. You will present one of the most iconic buildings erected more than 30 years ago in the Frankfurt area, Commerzbank, which is now more or less the global tower, it is called. But I found something in addition in Düsseldorf, as far as I remember, La Tête.
La Tête.
Yeah. And La Tête is your head, so it's think twice. What I found pretty interesting, it's on top, and it's really towards the Toulouse Avenue. It's really a building on top of the former transport railway station. And you made a kind of vertical emphasis when it comes to playing with white and with black. So you made a kind of coding of architecture. And now I'm back to my architecture has a meaning. Can you help me to decode architecture?
To decode architecture.
In your
I
presentation.
try to.
Okay.
I try to.
Thank you, Holger. Yeah.
Thank you for the introduction, and I'm happy to be with you today. So, Holger from Holgermeyer Architects. I just want to tell you a bit of us, just to begin. We are 100 architects working in Frankfurt, Munich, and in Bucharest. Here it's just the three of us. It's Holger, Gregor in the middle, and Martin Schapfeld, my partners in crime, I would say, which are running the office all together. We did quite a lot of work in office buildings, and here we are just showing some examples. It's the St. Martin Tower in the west beginning of Frankfurt, the Taunusanlage 8, the Frankfurter Volksbank, and so on, and the Michaelsberg, where we won 2 MIPIM awards. It was one of the buildings, I think the only one German project, which really won the 2 awards, the Special Jury Award, and in the hospitality category. Why I'm telling you a bit of Michaelsberg, it's also a refurbishment project, and as in the introduction explained, we are working quite a lot of in refurbishments because we think we as architects, we have to keep much more an eye on the existing structures. It's a story of decarbonization using these structures. And I picked the Commerzbank Tower as a project today because it's focused on that target decarbonization using existing structures, doing good refurbishments, and playing with the challenge of a facade on an existing building. So we called it refurbishment of a listed former giant. Yet maybe somebody laughing about the giant, because I think the interesting point about that is that our eye on the scale of architecture has changed a lot during the last, let's say, 50 years. When the Commerzbank Tower was erected, it was, and you just see a bit of the 50s surrounding in inner Frankfurt. It was really a giant with its 110 meters. It was one of the real large-scale buildings all over Germany and was the headquarters of a very proud bank, the Commerzbank. which was one of the biggest institutes at that time. It's still existing, but it has a much larger building itself now. And you see it a bit in the surrounding now that the 110 meters in the middle of the skyline of Frankfurt are not even much recognizable anymore, because all the rest around is around 160, 180s and 200 meters. I know in Shanghai and Dubai we have much of different scales, but in the time when the Commerzbank was built, it was really in the surrounding and for the skyline of Frankfurt one of the most important and most visible buildings with its 110 meters. To explain the building, and that's a picture when the building was some years only old, completed in 1973. The role model for these buildings were the houses we all know. We just picked a few of them. It's, for example, the Lever House in New York from Skidmore, Owings and Merrill, and of course the Seagram building, which are symbols for the international style, and a role model for the building of the Commerzbank at that time. The Dreischeibenhaus from Hendrich Petschnig Partner is an example we took because it was refurbished also just some years ago by Hendrich and Petschnig and Partner again, and is quite a very good example of reusing an existing structure. The Lever House and the Seagram building, that's the interesting part of it, are both owned by one of our clients, RFR, which are owning these buildings, and they have a very great passion, both Michael Fuchs and Abby Rosen, for these landmarks building with really this significant history, and they keep these buildings really with an eye on it in the structure as they are. The Commerzbank is a bit different. The competition was in 1968. There was as well as a proposal of Mies van der Rohe itself in that competition, which we show here as a model. And the winner of the competition was Richard Heil, at that time a quite big architectural office here in Frankfurt. And the building was completed 5 years after it, maybe 6 years, in 1973, 1975. And then it had several modifications because it was the headquarters, it was the seat of the board of Commerzbank. There were many restructurings inside the building, but it has never changed from outside. And then the Commerzbank decided just next door building with Norman Foster, the new headquarters, which is still existing just behind it. It's just behind that building. And the old headquarters was rented out to the ECB and was used from the ECB when they started in 1997 in Frankfurt for, I think, around 15 years as a back office location for the ECB. And then we had to make a due diligence, a very intense due diligence for the Commerzbank as owner of the building for more than half a year. And then they decided to sell the building to one of our clients to take us over because we had quite a knowledge for the building. So the idea of the global tower, as it's now repositioned, came up in 2018 when the GG bought this building. The completion, here it's 2021, it's used, but it's not really completed. They are still working on some details on the ground level and the entrance hall, so I think it's finished in the next weeks. It's not all photographed and not really finalized, but it's close to finished. So the challenging point was that in the selling process, the monument authorities in Frankfurt decided to list that building which was a quite challenging point because in the interior everything has changed. The ECB killed really the rest of the original details of the house. It was inside when you came in, it was a typical 90s, not really recognizable or really special interior, which was all gray and white and quite boring. It was very functional, but nothing really special. But the original facade, they kept, and that was the main focus for the listing of that building. And so a very challenging and not really short process began. So the new owner really didn't know at the beginning how the listing will impact the refurbishment, and I think this was our main thing to deal with, how to really deal with this challenge of that special facade. And what came up in the due diligence of the facade process, it's not that it was only technical-wise, energetic-wise, and acoustic-wise, not really state-of-the-art. It was really perfectly detailed, but it was a complete steel aluminum facade, which was really cold inside and cold outside. It was really, from energetic point of view, not really refurbishable. It was, you couldn't deal with that facade as it was. The main thing was that it was decontaminated by asbestos, because they did all the fire division between the floors. They did by this asbestos filling you see here. So it was really complicated to deal with that details. We had some intense points where we had to deal with what the concrete construction of the building, and you see here pictures from the really due diligence process with the facade, which really took us months to do to deal with the right idea to handle these building in detail. These are quite typical points you see really in every refurbishment, and that's the topic. If you deal with these existing structures, you need, and you have to tell the clients, they need a process of 3 to 6 months during a really proper due diligence, that you know everything which really comes up in the next, in the whole process, to deal with this in front and to make the right decisions. The special point here was the preservation, the listing of the building, that begins parallel in quite a long process. So the facade had its typical structures, which we had to keep. When we design now a building like this, we would never close the sides like this, because we want to always have corner offices with a free view into the skyline. This building was completely designed differently. There were technical shafts on the sides. It was a double structure where all the ventilation shafts went up on the side of the building. It had a proportion of really not these transparent facades we are discussing about today. We have quite a high balustrade, which was in the existing building close to 1 meter. It was more than 90 centimeter high, the existing balustrade, which is really not a nice situation, because you're sitting at your writing desk and you're looking more in the sky than having a view connection to the city, and really this quality of a high rise, which is a bit lifting up over the surrounding buildings. But that was really the things which were the main issues for the monument authorities to keep that building listed, and we had to deal with these topics and proportions. We had to deal with the structure of the building. There was a speciality, and you see it here in the side of these planes. It was directly connected with the Norman Foster building. So at the time when Norman Foster built the Commerzbank Tower, the second one, they were not interested in dividing these buildings, so they were connected really not in a really straight way that you can share them in two buildings. So the first project was to divide the two buildings, and then we had to deal with the core structures and so on. But the general structure of the building was very good, and the result of our first due diligence, even for the Commerzbank, was it makes sense to keep the structure and to keep the building as it is and just to work with it. We have to examine all the situations where the old facade was fixed to the existing concrete structure, and we developed, and this shows here in detail, we developed a new facade, and that was the main idea we had. How could we keep the shape of these facade, which was really elegant? It had really small profiles, and you couldn't build that in a modern facade as we saw them today in the other samples. So we decided and discussed with the monument authorities, after we had a process of around 3 months where we had a discussion to keep the old facade or really to renew it. Then we made a decision together that the replique of the facade, which was quite a dilemma as a result of the due diligence, that the only thing which was really worth to be kept, we couldn't keep because it was technical-wise not really fitted to the uses we have in an energetic optimized building. So the decision was to make a replique with a facade which has really 2 layers, a double-skin facade, as we saw today in the other modern samples. So we designed an outer facade which has to keep the proportions of the old facade, and an inner facade we went out by 17 centimeters. The building was larger, which we are allowed by the German law. For energetic reason, you can extend the building without getting in trouble with the neighbors because new sizing the building. And the double skin facade has really the one chance to keep the old elegant design of the facade. We had the chance to implement sun blinds into the distance between the 2 facade layers, and we have an energetic facade which fits to all modern necessities, which has the profiles which are as large as they have to be, which has the elements which could be opened, so you have natural air ventilation into the office spaces, all that which you couldn't do with the existing facade because it was completely closed, because there was an air condition behind, you couldn't move any of the windows. With this double layer facade, it was possible to open it behind, and what were also changing was the grid of the facade. It was possible the old facade has a grid of 187, which is a quite unusual grid for using for modern and flexible offices. So we decided to divide it by half. You see it here. You have the possibility to have some dividing element for offices in the grid of then 93 centimeters, which just allow us to work to handle with quite normal office sizes in the inner structure from 270 to 80 to normal sizes of offices. So really to optimize the flexibility. The idea of this, and you will see it in the next slides, is that you couldn't see that functional facade because it's mirrored by the first layer outside. We have to change everything in the inside, but that's not really the topic today, but you see it in this section. We have quite a low situation in front of the windows. What we did is a trick that we reduced, and that was really the most intense discussion with the monument authorities. We pushed the balustrade down because we wanted to keep the proportions of the facade, and with the trick to reduce it, to push it down by 30 centimeters. The balustrade in the room was very low. It was only a 30 centimeters balustrade, and the inner facade, the window, is larger than the outer facade, so that the proportions are kept outside. The windows is maximized inside. The balustrade is pushed down, so you have mainly the quality of a new building implemented into a really old structure, which is only a height of 250 in the facade. That's one problem, but we couldn't change that beam. But we lifted up the ceiling here to a maximum height of 280, which is really the minimum. But really to combine it, we have an overall floor height of 235 in the existing structure, which is for a modern office building too low. When we deal with a modern structure, we are discussing about heights 350 at minimum, up to 370 to 380 in high rises, to get really good room quality. On the other hand, just demolishing that whole structure to rebuild a building by the same height, which has less space because the floors are higher, you lose 2 floors. That's not a difficult thing to calculate, that this is not working overall. It was not possible to discuss here high-rise, which was 50 or 60 meters higher. That was the case we examined for Commerzbank before they sold the building. Is it possible to make a higher building on the plot before it was listed? But all these points show how intense the concept phase must be in such a building to make the right decisions for refurbishment. But to focus on the facade again, here you see the structure of the building, which is quite simple. It's really these two elements with an inner core, and here you see these shafts which are on the ending of the facade, with these typical corner elements here. And so the structure is quite simple and it works well. And so we really kept our focus on the facade. You see here the sample facade we built together with our facade engineers, and we made a sample of these corner elements. We built these top elements, and here you see a point which I will mention later on a bit. That we have to deal with these top floor, which was a very large technical area on the top of the building, which was not used anymore. So we had to reduce them, but the monument authorities insist that the structure of the lamella structure has to be kept. We proved them that in the competition it was 1 floor less of technical installation, so that one could be redesigned in the normal facade, but the other 2 floors could be reduced to 1, and we used that one as a conference area with glass behind, was we had to keep the lamellas, and then we left only 1 floor for the technical equipment on top. What you see here as a result, and there was the old facade we took away, and you saw that really typical vertical elements which went over the 110 meters as one vertical element. There were no profiles. The windows were not, you couldn't open them, they were just closed. So the new facade with the 2 layers has really the same proportions. You see here that we really had a long discussion with them of having this reduction of 30 centimeters, reducing the balustrade, which I think really is not a problem for the proportions of the whole facade. I think it keeps its elegancy. And what you really see here, if you focus, you see the new profile, which is just behind, but it's not disturbing the structure because we decided to do it in 2 colors. We have the bronze tone. We had to make an analysis of the old facade. It's an eloxal, and we had a long discussion about the tone because it's changing over the 50 years quite a lot. So they made an analysis to really keep it to the original and perfect tone. And here you see the situation of the lamella facade with the technical infrastructure. This is still a technical infrastructure, and here we reduced it and have behind it 1 floor with the conference areas on top. So we think it's quite a match from the material and from the proportion, but it's a new facade, and the monument authorities are really happy. They are showing that as an example, and I know not only in Frankfurt, but all over Germany, as an example how you could deal with the challenge of keeping a proportion of that building and leading it with a new facade into the next generation of a modern office building, which really can handle all the functional, energetic, and technical issues we have to handle in a normal office building, because they also understand that for energetic reasons, we can't keep these old facades 50 years old for office building. That's completely different than keeping a small house which is 500 years old. But it's a long discussion, and you have to convince them in every detail. And that was not 1 meeting, and it was not 2 meetings. I think we had 10 times sitting together, clearing every detail. After we get the permit, we have to show them details. We had to show them the sample facade. We had to show material samples. That was not really an easy way for an architect, and the client also understood that it's very important to take care in detail with them in the discussion, everything that the process is going properly. Here you see a detail of the facade. That's the double glazing, where you have the air ventilation. The problem is you can't close it as it was before. That was also a detailed point to discuss how large this have been. We made some studies in a laboratory to simulate the air ventilation going up and out, or going in and out in this inner facade. So we agreed on, they agreed on 8 centimeters on top and on the bottom of these glass. But I think that it's also not disturbing when you see the facade. From the distance you see it, you really can't recognize. You just see here a very small line, which is not disturbing the proportions of the building. But the discussion is always in this detail about the proportion of such a point. We discussed every line here. Is this 2 centimeters? Is it 3 centimeters? How is the distance of these profiles? So that was quite a long way, and you now see it here from the inside. It looks quite as a modern facade. You don't have the impression of these high balustrades. In the existing building, the balustrades finished close to that point, and that's a complete different appearance of the building, a complete different feeling of the office space. And you see here that the beam at the facade is not really a problem. I think we can handle it because the suspended ceiling was pushed up to the 280, which was the maximum we could reach by keeping the existing ceilings. The grids, I've already explained, was quite a challenge. The 187 you can't deal with. It's the smallest room was 360, which is not really, you can't explain it. For example, for a law firm as a tenant, it doesn't work because the rooms are getting too much, and then the rental price per square meter goes down because it's not that efficient that it has to be, or it is in comparison to a new building. So that's why we came up with the idea of dividing that grid by half, so you can really be more flexible in finding the right room sizes. That's another impression from the internal facade, and you see here that it's really, you can open that facade, you have the feeling, and you have the same usage if you have it in a newly built building. That's some samples for the old Haustechnik, and here you see the old facade with the balustrade element before we completely demolished it, and you see this is really a complete different situation and a complete different feeling of these existing atmosphere in the office. What was really quite interesting when we went into the history of the building, there was in the original idea, there was a roof terrace here on the plinth building, which is quite large at the corner here of Neue Mainzer Straße. This was completely closed over the years because they built in IT technical areas, and the facade was completely closed. We reactivated it in discussion with the monument authorities and the client, because we think these terraces at the level of I think 20 meters is very, very interesting place to use it. You just see it here that it's quite wide because you have quite a deepness, good to use. And here are the points which I already explained with the reusage of the technical space on top of the building, where we implemented additional office space. Another point was the entrance situation. The building, when I first explained we are working on that building, there were quite a lot of people who said, well, what building is that? Commerzbank, because it went forgotten because it was just rented out by the ECB. It was completely closed up. The very nice corner conference room at the corner of Neue Mainzer Straße was used by the ECB for, I think, 10 years as a furniture storage in the best location of Frankfurt, and we decided that it's much better having the lobby in that area. But we had to convince the monument authorities that we have to lift it up. It was in the existing situation, and that was the storage furniture of the ECB at one of the most prominent corners. And it was the former entrance hall, and that it's not really visible. And we really discussed, we wanted to have three floors high. We have opposite the new lobby of Bjarke Ingels. On the other side, we have the other building, the Taunusturm of Tishman Speyer. They're both Tishman Speyer projects. And then we convinced them that even for the visibility in the city and for the activity in this corner of these three buildings in the surrounding, it must be much more representative, and so we decided to lift it up. By then 2 stories, I think that's okay for the proportions of the building, and it's really quite representative, but it's an important gesture as an entrance for a building of that size. So you just hear some pictures. There was no entrance, and it really hasn't any quality. It was just for security reason. There was one revolving door after the other, and we opened it. And that's the idea. It's not finished. That's the one that's still a rendering of the terrace. which was reactivated and reopened here in that area. What is really interesting, I think it's the only corner in Frankfurt with 4 high rises on each corner. So it's the only one where you can really say you have a sort of New York feeling. And I think the gesture of big here with the setback of the apartments in that area is it's really quite amazing to see in that situation. So, and here it's all together with Taunusturm, Japan Center, the Omniturm from Bjarke Ingels, and the new facade of the Commerzbank Turm. And I hope I really took you a bit through the story of the development of this building, which was quite a challenging one for us, but really an interesting one. And thank you very much.
The question is, when you work with revitalizing buildings, and you have said you work with a monument department, and how much pain, how much fun is it, and when is the point when you say it's better to run away?
Well, the client has to accept first that it costs time and it costs money. And that's not easy. Yeah. So we are a bit in between. I've always say we have a mentor role in between the maybe too hard defined restrictions by the monument authorities and the just, of course, money driven because they paid a lot of money for the building. Money driven, I don't mean it bad.
Not piggies, no.
Yeah, no, that's okay. And that's the in-between process we have to handle. And the fun is when you really deal with it and you have some success. For example, when we had the meeting and we convinced them to really reduce the balustrade in height and in the location. And that was really a win situation for the quality of the office rooms. And then was everybody happy. And when we agreed that we could do the inner facade with another grid than the existing one, when we started, they said, no, the proportions, it's 187, and it stays like that. And then we made these renderings and to show them how the proportion does not really be affected by these functional optimization, which is necessary. And so when you have some small steps where you're winning, and everybody is happy after that, then it's fine.
Excellent. So more or less making this revitalization also
but it takes time, and it takes some nerves. And for us, just to say from the planner point of view, it really cost us money because it took so much time to convince everybody to go that way into the next step. That's different than just explaining a new concept.
And this means you need more than just the time and also the money to do for it. It's the passion. It's the architecture in passion, or passion in architecture you have shown in that project. Holger, thank you so much.
Thank you.
Brilliant. Thank you. So, last but not least, Simone Stannini is coming. He's from Sir Robert McAlpine from London. He's head of Facade. He will bring us definitely some light into the building activities, hopefully mostly in UK and London, because for us it has been quite of an eye-opener the past months. Being in London, discussing with a lot of people in London, and seeing how much decarbonization is really pushing through the construction industry. Normally you think the guy who's investing is just there for the money. The contractor is even there just to save the money and trying to find someone to squeeze out at the end to make the facades. When you see how London is doing the work now, and I hope you will emphasize a little on that one, you see how much enlightened the industry could be if everyone is starting to think decarbonization. London Energy and Transport Initiative, this is something I learned by heart. is giving me a lot of hope that we in the construction industry can do a step change for the planet. Looking forward, Simone, for your presentation. Looking forward to.
Thank you very much. I'm going to be, I know it's late. Thank you for being here. Thank you, Werner, Henri, and Wicona for hosting us. Yeah, of course, Letty, which is this initiative in London, is a strong driver in the UK. What I want to talk to you about today is a project called the Francis Crick Institute. Francis Crick was a neuroscientist, a biophysicist, and a biologist who won the Nobel Award in 1962 for modeling the DNA and the genetic code. This project was initially called UKCMRI, United Kingdom Centre for Medical Research and Innovation, and then named after Francis Crick, and it was funded by a consortium of a number of research and medical institutions. So Wellcome Trust, Cancer Care, Cancer Research, Medical Centre, Imperial College, King's College, UCL. This was a consortium of companies that was the client for us. The designers were PLP Architecture, a very well-known practice, under the lead of Wayne McKinnon and Rob Peebles. I hope, okay. The building is the largest biomedical research facility in Europe, and you probably won't be able to appreciate the scale of the job until you get there. I've took some pictures more recently to give you an idea of the dimension of the project, which is massive. It's a very big project, and it's 170 meters long, 80 meter wide, and 50 meter tall. There's 1 million square feet of research space, which is nearly 20 football pitches. And there's 1,500 people working there, most of which are scientists. It had a bit of a long story, so PLP had been on the project for quite some time, and then we started being engaged in 2010-11, and then it started, the cladding started in 2013 and was finished in 2016. The building had a very strong identity. It had to be best place for research, collaborative environment, inspirational work, place to work. And it was settling in a very difficult and characterized urban fabric. This is the building, and who's familiar with London View. So we've got the Renaissance Hotel, which is a monumental building. We've got the British Library. We've got King's Cross and St Pancras Station. So very strong characters of the city, but also some residential part of it. And the building had to settle within that texture. The facade design had a number of different cladding types. So we had the roof, we had some solid cladding, we had some vertical slats, glazed slats, terracotta, vertical glazing, PV cells, again terracotta, the diachroic glass on the atrium. So the facade design that was conceived by PLP was translated into proper engineering design, and I'm coming from this subcontractor background, by a company called Skelgebau of the Permasteelser Group, very successfully. This is not necessarily what I want to talk to you about. What I want to talk to you about is how we got there, of course, through the process of visual mock-ups and an iterative process, but a unitized cladding, which you all have seen. So the challenges that this project faced were a number, and some of which were very, very difficult. And I'm glad to have here today architects, subcontractors, main contractors, because I think there's some good ideas that we could bring back home. The design was extremely demanding. The architecture was extremely demanding. The envelope was very complex. The specifications were written by a consultant called Emma Fenninger, most of you may know. And it had 41 different cladding types. The requirements were all very onerous, very stringent, very difficult to achieve. And the cladding types, as I said, 41 of them, all of which involved interfaces. This is a design stage. Then when we got to procurement, we had a very fragmented procurement. We had different systems that had to be procured from different companies. And on one end, the client had wanted cost certainty, and we had to avoid scope gaps. Of course, at delivery stage, we had a program to meet, and again, these clients, this consortium of very important institutions wanted certainty that the quality that they wanted could have been delivered on time. So what did we do? We thought from day one, we understood that in order to deliver this quality, we needed to have strong facade competence, knowledge. So on this job, we appointed a very capable facade engineer who took the project from tender to, I would say, probably installation stage, and a super competent construction manager. Both had about combined 45 years experience in facade. That was the first key item. Then we started investigating, interrogating the initial design produced by the architect, identifying what we thought could have been risks that had to be tackled and mitigated. All cladding types were identified, and we put together at a very, very early stage a schedule of interfaces. And then again, I want to stop here for a second. When I say we, this is, as you've seen, is a very large project. I'm just one player in a big team, so I'll come back onto this one. A schedule of all the interfaces that we had to develop. The other problem we had was at procurement, so many different cladding types, all these different subcontractors. How do we deal with all those scope gaps and interfaces? We adopted what we called the large umbrella. So rather than having a number of subcontractors, we decided we want to speak to one single subcontractor and put everything into their package. This is exactly what happened. All these subcontractors here, giving different products, were all included into a big package that we procured from one single company, Skaldebauer in this case. The other issue we had about cost certainty, time constraints, and design development, we could not have achieved this just with competition, tendering process, and minimizing cost and maximizing profit. We decided to engage very early engagement with Skaldebauer, the cladding subcontractor, on a PCSA. And we didn't have enough design information at that time. So how did we achieve that? Well, we mapped out a bit of a process, which we decided to call exotically the roadmap to incremental fixity. So an iterative process by which the design team produced an initial set of drawings and specifications that then were allowed the facade subcontractor to develop a design that then was reviewed, commented and reviewed, and adjusted, and then agreed. That design, that initial design, system design, was priced. So we had a set of drawings, sections, and a price that we're all happy with. That set of key details unlocked a further set of secondary key details that then went through the same process. At the end of this two-stage process, we had about 150 drawings that the architect was happy with and had approved, and a price tag attached to those drawings that the client was happy with. So this is the way we identified key sections together with the architect. So we thought this would have been something to develop for all elevations. A very simple marking exercise, a bit old-fashioned. And a schedule of all these details and the information that had to be released. So that was the early engagement. The project of this complexity could not have been delivered just with the standard inspections or spot checks on site. So we introduced, together with the architect, again, when I say we, there's very little of me. We introduced a number of innovation and good ideas. The first was regular visit at the fabricators. We decentralized the quality checks, the quality inspections. So there's no point in having a material coming to site that's not good. So we had the terracotta suppliers, we had people going at the terracotta suppliers regularly inspecting the materials. We had people at the glass suppliers, people at the steel supplier, so that we had certainty in deliveries and on-site progress. We had a number of combined full-scale mock-ups. There were only 3 mock-ups priced in a very generic sort of pricing document. Fine, let's try and maximize that. So we combined a number of mock-ups to have all the cladding types together. 3D printing, PLP were at the forefront of that. They came to meetings with ideas, and rather than having sketches, they had 3D printouts at various scales, from building scale to small detail, that we all started looking at and playing with. And equally, we tested the facade, combining various facade types. Someone who's much cleverer than me quite rightly said that if you always do what we've always done, we will get what we always got. So we had to start thinking out of the box. And then the other approach that I want to talk about, I've called it the Hubble project approach. Very few of us had any experience of medical research facilities of this scale. However, in the team, so in the architect, main contractor, subcontractor, consultants, we all had this feeling that we were at one of the peaks of our career. We were doing a fantastic project, a Hubble type of project, a one-off. Being a one-off, none of us had any experience, but we did our best to contribute to it. So the company individual interest did not exist, no barriers. I mean, we are still meeting for drinks with the team. So we worked hard. We always have hard times when you work in projects. You always have challenges and difficulties and problems. But it's great when you've got someone on the side that can work with you, help you, and you can trust. So this spirit was probably the greatest engine or the fuel we had in our engines. So if someone had to ask me today what made this project a success, well, I could probably say all of these. So the umbrella, the Hubble approach, competence, facade knowledge, early engagement, decentralization, innovation. But you don't get success without all these combined elements together. Now, I want to take you through what did that mean? What did that result into? Well, as you see, the building is quite large and articulated. So we've got the atrium, we've got the curtain walling, the roof, and some closed cavity facade as well, which I'm quickly going to take you through. So this is the atriums, and the atriums bisect the building in four quadrants, actually, longitudinally and on cross section. So what it happens is they need to provide light to this very deep building, because the top of this building is occupied by 16 meters of plant and equipment, because the experiments that are being carried out here need to go on for about 5-10 years, and everything needs to be double as a backup, so they can't be stopped. And this is how it looks from the top. So we've got the one atrium and the other. The curtain walling, we've got two main types of curtain walling, generally speaking. They occupy the two long elevations. And it was a standard unitized systems, but with terracotta cladding. And then the roof, which was a prominent part of this building, it was the reason for having the roof of this type is because architecturally there was an intent to replicate the whale, a big whale, and I think it's been successful as an intent. So it's been these two halves that overlap. It's been subdivided into parameters. Every panel had a shape, had a code, a relatively complex type of design, which was delivered quite faithfully to the original design intent. And then the closed cavity facade at the end of these two gable ends, where the highest performances were required. Again, I've said. I kept saying we throughout this process, and again, that we is a number of people that made this job a successful one, without which I wouldn't be here standing in front of you. I've tried to keep it as short, as simple as I could, because I understand the time is late. So thank you for that. And if you're not, thank you.
Simone, you must be an engineer because you really rushed and made it happen that we are on time.
I am an engineer.
Yeah. The question mark in what you have shown us today, you said at a very early stage, PCSA, you involved the contractor, the subcontractor of the curtain walling part, Scheldebau. Why is industry not doing it more often?
This is key, this is essential. I believe sometimes most of our projects are driven, and I should be saying this, but I will say that anyway, are driven by cost and cost consultants, which sometimes impose competition or limit our good ideas from coming in. So I think this should happen more often. We, as tier one main contractors like the one, Sir Robert McAlpine or many others that are here today, we do know the market, we do know subcontractors, we do know who is good at what. So I think we do need their help to progress the design to an acceptable state. And PCSA's pre-construction service agreements are absolutely great tools that we would like to have on all projects.
When it comes to your investor for that kind of building, how hard was it to convince him that this is the right approach for that building?
Well, talking about London is a bit of a different planet, as you quite rightly said. In London, you've got some clients that we discussed last night, we call enlightened clients, that are prepared to spend money for a good cause. These institutions here, they're all big, large institutions. Of course, they don't throw any money away, but they are aware of the value of what they need to deliver. So if we're talking sustainability, if we're talking medical research center, then value is very important. So they're prepared to spend some more money to get what they need.
And I just try to then bridge back to the introduction. I mean, I have 100 Liverpool Street in mind. When I think about the next challenge of our construction industry, it is BREEAM outstanding. It is zero emission carbon building. You have used a lot of concrete slabs again. Even more or less the pillars, the fundaments, you have been able to redo once more. How difficult is this to convince people to keep the carbon discussion in the mind of the people?
Again, being involved with the whole of the country, I see a big difference between London and the rest of the country. In London, as I said, there's initiatives like Letty that are pushing the sustainability factor to a very high degree. The rest of the country is not at the same pace. We were talking recently about the carbon tax. So investors start to understand that in the near future...
£70, 70 pound a square meter, I've understood.
So the investors are starting to think, well, if I don't deliver a sustainable building, then I'm unlikely to be able to sell it because there'll be a very big tax tag that I will have to pay. So that is what is driving. It's not the same in the rest of the country. It's still a bit behind, but I think we'll get there. We'll get there.
Excellent. Simone, thank you so much for being here with us.
Thank you.
Just stay with us, Simone. Simone, just stay with us. I would like all speakers coming back on stage again. Also to say thank you and goodbye to the audience out there in worldwide things. So Timo, just come in. Torben, if you like, please just enter. Where's Oliver? Where's Holger? Just come back again. Come back on stage. And please take the audience applause for brilliant presentations. Thank you all, and we have said, I mean, the camera is still on. I mean, I know it is 2 hours and a half, and it was superb on time. Thank you so much for this discipline. It's excellent achievement. Nevertheless, the audience might have still some questions here and there, and maybe we take 2, 3 questions, maybe 5-ish questions, if you like, if you have just some questions for one of the speakers. Yes, please, come on.
If you would do that project all over again, what would you do differently?
Good question.
Can we sit down while you
I've got the think that probably the project so far, I think it's there's a lot that really I've tried to replicate in other projects. What I would do differently, it's probably a bit trying to rationalize earlier the facade design even more, because we ended up rationalizing it, but still having 41 cladding types. So reducing it to 20 would have been great.
Any further questions from your side? Don't be shy. Of course, the fridge is full. The water is chilled. That's no problem, that one. Maybe the final question to the architects in the room. So we have 4, at least in front of us. A question which, take it brief if possible. What makes you awake in the morning and be thrilled to go back to the office when you think about your architecture? Oliver, you must start. You have the mic.
I have the microphone.
No time to think on it.
That's easy to answer. It's just, I think our job is just like, we have so much fun creating stuff with a team from all over the world, such an international crowd, and it's just, I don't know, we just have a great time in the office and we love what we do, so that's easy answered. Mm-hmm. Yeah.
Excellent. Thanks, Oliver.
But I still really never know how the day ends.
It's very important to keep the eye on the money. I think that's
Yeah, actually, I really like the job, so it's really, I love doing that.
Yeah.
Yeah, same for me. Same for me.
I
think, I don't know. I don't know if I'll ever retire. If I'll retire, I'll probably keep doing this anyway.
Exactly. Excellent. Thank you all so much. Thank you all for this 2 hours and a half and a little bit extra time just to have these famous discussions and good speaks. And the fridge is open now, and looking forward to see you soon again. This was the 5th International Next Facade Summit. Looking forward to see you and host you soon again. November is the next one. I've realized Christian, the chief organizer of that next studio by Vicona and Partners, is going to do the introduction as soon as he can to you as the audience. And thank you all out there, and especially also here in Frankfurt, being with us and giving us more or less this human feeling back again after 2 years and a half of pandemic. So thank you so much, and give the applause to you as well.
Thank you.
Thank you. Okay.
Discover Next, the studio for facades and design. Next is the platform for innovation in the field of building envelopes, for inspiration, information, and communication. Initiated by Vicona, with leading industry experts as Next partners. Next is a unique concept which is constantly evolving and bringing the future of cities to life.